one left off. So we're talking about winds, and we'll be talking about different types of winds. But let me assure you that what you learned, I feel like Bernie Sanders, what you learned, I like his, what you learned, actually, in the previous unit is the way this works too, okay? So all winds are air going from a high to a low pressure. So we're going to talk about 3 different scales of winds. We're going to talk about the big scales of winds called macro scale winds, okay? Yeah. And they're not only big, but they last long. And then we have the middle ones. They're called mesoscale, meso kind of middle, mesoscale winds. Those are kind of large, but not as large as the macro scale. And they last a long time, but not as long as the macro scale ones. So we have mesoscale winds. Example of a mesoscale winds would be our thunderstorm systems, tornadoes, which are smaller than the thunderstorms, sea breezes. We'll talk about sea breeze again. And then kind of going down in scale, we have our microscale. Microscale means that both they're small, they don't cover much area, and they don't last very long. So for those of us, aren't you just fascinated by dust devils sometimes? Just like,
yeah, cool.
They are cool.
Unless you have to drive through one, then
yeah,
that's so cool.
Yeah, because they can be pretty powerful. Yes, so dust devils. They're relatively small and don't last very long. Okay, so here's a figure from your textbook, and it's good from left to right, micro, meso, and macro scale. And then I like what it does, your author does at the bottom here, because he kind of goes ahead and he says, with regard to how long do they last, that's these first 3. And then with regard to how large are they. Okay, so it's a pretty good. Of course, this one looks like we were talking about hurricanes. This one looks like a hurricane, doesn't it? Yeah. Which has a hurricane does have an L, a low pressure in the I. So I want to take a few minutes and just kind of talk about these middle ones. We aren't actually going to do much with microscale winds, but we're going to talk about mesoscale winds, and then when we come back from break, we're going to talk about planetary scale or macro scale. Okay, so these are just the smaller ones. And we're going to start with the one we already talked about. When I put my slides together, sometimes I'm like, Mrs. Snipes, I don't call myself Mrs. Snipes, but, you really should go ahead and pull this topic, just make it one or the other. But I want to talk about it one more time, this idea of a sea and land breeze. And remember, this actually was kind of similar to, if you're in Chicago, this is like a lake breeze effect, kind of. Okay, good. So we said that oceans, or large bodies of water like the lake, or oceans, actually they're really slow to heat and cool. So that's kind of what the crux of this. The other thing to keep in mind, and I'll just kind of superimpose it here, is that let's see, if it's warm, if you have warm air, is the warm air kind of a high or a low pressure? You remember?
Low pressure.
It is low. So warm air, and that's kind of at the crux of kind of the things we're going to talk about with these mesoscale winds. Warm air is generally low, so cold air is generally high. That will help you. So basically, these figures do a good job. What happens is that your Lake Michigan, if you're in Chicago, or your ocean or whatever, as the sun rises and it heats up the land quickly, the water lags behind. So the warm temperature of your land, okay, creates a low pressure on your land. Okay, so then what does that do? Basically, it's low. You have a high over your lake or your ocean, and so you're going to have air relocate and create a wind. Okay, so that would be your sea breeze or your lake breeze. We have an outgoing breeze then. Whoops. We have outgoing means going from the land back out to the lake or the land back out to the sea, happening at night, because actually at night your water cools down more slowly. Okay, so it retains its heat. Then the water has the low. Okay, and then we have your land cool down more quickly, and so you have a high. You have an outgoing breeze. Next, you want to go to Chicago to see if you can see the outgoing breeze. I've got the whole Lake Michigan thing down, but I've never had that one. So they kind of come in pairs. So you just saw a sea breeze and a land breeze. Remember, I think I said if you want to know where it's coming from, you just look at the name before the breeze. So now we have another pair of breezes. We have a valley breeze. Now hopefully if you're thinking valley, you're thinking kind of down between things. So a valley breeze must be a breeze that's coming from the valley and it's going to go up the mountains. And then we have a mountain breeze, what comes from the mountains down into the valley. Okay, so they're kind of paired together. There again, there are mesoscale winds. They're kind of what we call local winds. And the reason these work actually has to do with temperatures again. And at upper elevations, the air is thinner. And at upper elevations, that thin air will heat and cool more quickly. So again, as the sun kind of rolls around, it will heat up more quickly. And basically, at upper elevations, you create a low. So if you create a low at the top of your mountains, guess what? Okay, your air is going to go up. Okay, so that's why a valley breeze is kind of during the day like that. In the evening, the opposite occurs. In the evening, that thin air up there will cool more quickly, okay, and it will create a high up there, okay, and what's it going to do? It's going to go down, so we call that a mountain breeze. So you have valley breeze during the day, a mountain breeze at night. So, yeah, here's figures to go along with those. Okay, so this is your valley breeze, okay, going up. Now, notice that if your air is relocating, up the slope of the mountain, basically it kind of creates a vacuum here. So you'll actually have air subsiding there. And here we have the mountain breeze and air rising up the valley. Okay, so that was your second local wind. Here's another local wind. This one doesn't have a pair. This one is just what it is. The term Chinook, I think it may be in your textbook, I may have read it in your textbook or somewhere else, is actually an Indian name for snow eater. So these are the snow eaters. Yeah, if you want to put snow eater, you can. Yep. And the reason they're snow eaters is because they are very warm. So what do I mean by very warm? Well, as this wind passes you, your temperatures can warm like 40 degrees Fahrenheit. It's just called a Chinook wind, yep. It's a downslope wind. We actually have a couple of winds associated with mountain ranges. This one's associated with the Rockies. The leeward side of the Rockies. Are we okay with that? I'm going to grab the... I'm bad about my mountain ranges out over here. I just kind of point to them all. This is the Sierra Nevada, isn't it? Okay, and here's the Rockies. Okay, good. So the leeward side. Okay, so we actually have, we're going to talk about this when you come back. The prevailing wind is kind of a westerly wind. So actually, this is the windward side, and this is the leeward side. So this is where the Chinook winds happen. They are basically a high hovers right there and basically forces the wind down the slope. And so what do we know about air if you can get it to go down? It's going to get smaller. Instead of expanding, it's going to contract, and it's going to heat up. That's exactly what's happening there. Adiabatic warming instead of cooling. So they can be pretty fast, and they're very specific. Where to go? Right up there. All right. Then we have the Santa Ana winds. I always think of the, I can't think of it now, but Saturday Night Live with the Rosanna, Dana. Yeah, been a while. But Santa Ana winds, I'm going to let Dirk explain them. How's that? Turn out like you want them to turn out. But I thought he did a good job talking about the conditions necessary for the Santa Ana winds. So the other, I think there's a couple more local winds, small or mesoscale, medium scale winds to talk about. The katabatic winds, I like them. What they need is a plateau, and if you remember in your, days in high school, remember you learned what a plateau is. Basically, it's flat with kind of sharp sides. And Greenland is a great plateau. Where did you go, Greenland? Okay, it's a pretty good plateau. It's got like steep edges. Okay. And the Antarctica is another good one, kind of steep edges. So what happens to create katabatic winds is, and it works well, the two places I said, Greenland and Antarctica, they're like really cold, right? So what can happen is the cold air can build up, and you guys told me cold air has a high pressure. So the cold air can kind of build up and just set on the top of the plateau. And it's kind of like if you've ever kind of played with water on something that's water repellent. Basically, sometimes you pile up the water and then the water just finally kind of rolls down. That's kind of what happens with this high pressure. Eventually, it just kind of falls off the edge. And since it's a plateau, there definitely is an edge. And so it's that kind of falling off that creates these katabatic winds. So the katabatic winds can redo themselves. They just kind of build up and they do it again. And then I think the last one, before we get to the large-scale winds, is this one, the country breeze. So this actually, if you remember something called the urban island heat effect, I think I mentioned back in maybe chapter 3, the cities tend to retain their heat and that sort of thing. If cities retain their heat, okay, they can actually, the city can kind of create a low pressure. And so what do we know then that happens is outside of the city called the country, you can get movement from the country into the city. So that's what the country breeze is. Okay, so, and these would be most predominant as the earth is trying to kind of cool down as it's becoming nighttime. So these would be country breezes. And like it says, the country breeze can actually, if you have wind coming from all directions, kind of making the city keep what it's got, including pollutants, it can aggravate pollution. Very good, because the next slide is this one.
I notice there's always a warm bubble over the Keokuk area when I look at this
Oh,
temperature
okay.
map.
Interesting. So it's got the urban island heat effect going. Keokuk, Iowa.
And it's near the river too.
Okay. Very good. That makes sense. Okay. Well, that's all I have for today. And I'm letting y'all know. See spring break. Let it begin.